Hello and welcome to the presentation. I'm just going to do two questions on electricity and magnetism from the IGCSE papers. Okay, so if you just read the menu so you can familiarise yourself. Right, pause the video and read this question. Okay, hopefully if you've read this question you will have realised you're being asked a question to calculate the current in the circuit. If you read this bit, you're told the EMF of the battery is 6 volts. This causes 90 coulombs of charge to flow through the circuit every 45 seconds. Normally when you see the word current, you'd probably think of the formula V is equal to IR, or Ohm's law. But unfortunately we don't have R, so we can't calculate I using V is equal to IR. But we can use the definition of current to calculate the current. The definition of current is the number of coulombs of charge flowing through a point in any second, measured in amps. And if you were to write that out in short form, it's I is equal to Q over T. Q being number of coulombs, T being time. Okay, so 90 coulombs in 45 seconds. If we divide through, we'll find out how many coulombs per second. 90 divided by 45 is 2, and that's amps. Okay, you would get a mark for the correct answer and a mark for the correct units, but always write down the formula you use because marks can be awarded for that if you make mistakes in other areas. Okay, the second part is calculate the resistance of the circuit. Okay, well now I have V and I've calculated I can use V is equal to IR, rearranging for R. So V is equal to IR. I need to get rid of the I on this side. I can do that by dividing both sides of the equation by I. Cancelling out the I's, I've got R is equal to V over I. So V was 6 divided by I was 2. 6 divided by 2 is 3, and the units of resistance is ohms. Okay, calculate the electrical energy transformed in the circuit in 45 seconds. Okay, well basically electrical energy is the power equation, which tells me the number of joules per second that's being supplied or delivered by a circuit, and multiply that by time will tell me the total number of joules in that time. So it's energy is equal to VI, which is for power, multiplied by time. Okay, so the voltage was 6, I was 2, or current was 2, and the time is 45. So I need to get my calculator. Right, so I've got 6 times 2 times 45. 6 times 2 times 45. 540. Nice. 540, and units of energy are joules. Okay, this next thing it says, explain what is meant by the term EMF of the battery. Right, EMF stands for electromotive force. And I'm just going to put a definition here which I think you should memorise. The EMF of a battery is the number of joules of chemical energy transferred to electrical energy for each coulomb that passes through it. Okay? EMF means the amount of, basically the amount of energy per coulomb. And yeah, it's distinct from voltage, but it's a bit of a complicated concept to explain at GCSE level. So really, just memorising this is the easiest and most guaranteed way of getting the right, the marks in the questions on this subject. Okay. Pause the video and read this question. Okay. The question says a transformer. Okay, let's remind ourselves what a transformer is. Transformer looks something like this. It's an iron ring. You have a coil of wire on one side and another coil of wire on the other side. One side's the input and the other side is the output. And you put a voltage and a current in, AC, and you get an output, and you can either step up or step down the voltage. Alright, First question says calculate the power output of the transformer. Okay, well if you read the question carefully, it tells you the output voltage of the transformer and the current that's coming out of the transformer. Power is simply voltage times current. P is equal to VI. So I just need to put the numbers in. 24 times 2. Okay, and power is joules per second, or you can put it in watts. Okay, both units being the same thing. And remember, you get a mark for the answer for the units, and always write the formula. Okay, the voltage applied across the primary coil. Okay, when you look at this, you're probably thinking, if you've studied this before, you're probably thinking, the formula for transformers, I remember that. It was number of turns on the primary coil, NP, over number of turns on the secondary coil is equal to voltage at the primary divided by voltage at the secondary. But unfortunately we don't know these numbers here, so we can't use this formula. But we're told in the question that the transformer is 100% efficient. If it's 100% efficient, that would mean that whatever power is entering this side will be equal to whatever power is coming out this side. So the product of V times I here is going to be equal to the product of V times I here. So I can write a different equation. Power in is equal to power out. Right, I know the power output is 48 watts. And to calculate the power in, I need to know the voltage, which is the thing I don't know. So this is the voltage on the primary coil, but I do know the current, which is 0.4 amps. Okay, so I can get Vp on its own and calculate it. Divide both sides by 0.4. Vp equals 48 divided by 0.4. So let's get the calculator. Uh, 48 divided by 0.4 equals 120 volts. 120 volts. Okay. Explain what is meant by the statement the transformer is 100% efficient. Okay, I briefly spoke about that here when I was talking about the product of VI here being equal to the product of VI here, but I've just written that out neatly there for you if you'd like to pause the video and read that. Explain how the transformer changes an input voltage into an output voltage. Okay, this whole question here is worth 4 marks. That would probably be 2 marks for this one and 2 marks for this one. So in this question you probably don't need to write quite as much as I have. The primary coil has an alternating current flowing through it, this coil here. This causes a continuously changing magnetic field to be produced. Basically this becomes an electromagnet, this iron bar. And because it's an AC voltage, the polarity of that magnet is changing continuously. Okay. The secondary coil sits inside this field, this continuously changing field, and has a voltage induced within it. Basically the dynamo effect. It's like you've got a magnet spinning round right next to this coil here. Okay? That causes the induction of a current and voltage in that secondary coil. And then just to go for gold here, I've written that the ratio of input voltage to output voltage can be changed by changing the number of coils on one side or other of the transformer, just as explained in this formula here. Okay, hopefully that's been helpful for you. Thank you very much.